20 ml of the 0.001 molar silver nitrate solution is mixed with 1000 ml of the 0.002 molar potassium chromate. So will there be any kind of a precipitation? And the solubility product of the silver chromate is this one. We have discussed it previously that in the previous videos we have learned that if the ionic product is more than the solubility product, right? So the solution, is supersaturated, and only then the precipitation can take place. This is what we have learned. The precipitation takes place only when you have a supersaturated solution, which means that the ionic product should be more than the solubility product. So if you look at the final solution after you mix the two here, we're going to find out the concentration of the silver ion and the chromate ion, and that will give us the ionic product, and we can compare that ionic product with this value, the solubility product of the silver chromate, because we have learned that if the ionic product is equal to the solubility product, which means the solution is saturated, right? Okay, so the solution is saturated, and if the ionic product here is less than the solubility product, the solution is unsaturated here, and you can add more salt in that case. Now if the ionic product is more than the solubility product, that means the solution is supersaturated, and then the precipitation will take place. So this is when the precipitation can take place, when ionic product is more than the solubility product. Now let's find out the silver ion concentration and the chromate ion concentration when you mix the two different solutions. So actually we have a beaker that contains two solutions. We have mixed here, let's say the 1000 ml, we have 1000 ml of the potassium chromate, K2CrO4, right? And the concentration of this potassium chromate is 0.002, right? This is the 0.002 molar. This is the potassium dichromate, potassium chromate. Now we are actually adding in it, we are adding here another solution, which is the silver nitrate. We have a silver nitrate solution, and we are adding to this solution some 20 ml, right? We are adding some more 20 ml of the silver nitrate, so 20 ml of it, and the concentration of the silver nitrate is 0.001 molar. Now let's first find out the concentration of the silver, right? Okay, the silver ions. The silver ion concentration, we can find out from this 20 ml. Okay, how we can find out? We know actually the concentration of any solution is actually N by V, the number of the moles by the volume of the solution in the liters, and we can use the N, we can say N, the number of the moles, will be equal to concentration of the solution times the volume of solution in the liters. So we can use the same formula here to find the number of the moles, right? Let's first find out the number of the moles. The number of the moles of the silver ion, the number of the moles, right? The number of the moles of silver ion here, the number of the moles of the silver ions here will be that will be the concentration, which is 0.001 times the volume of the solution is 20 ml, which is 0.02 liters. So now it will be 2 into 10 to the power -5, right? -5. This is the concentration, this is the number of the moles of the silver ions. Okay, now when you have a final solution, in the final solution, the final solution has a volume of how much? The final solution has a volume of, actual volume is 1000 ml of this one, plus we have 20 ml of the silver nitrate. So the final volume will have a solution of, a volume of the 1020 ml, or you can say it is in terms of liters, it is 1.02 liters, right? So this is the volume. Now finding out the final concentration of the silver ions, what is the concentration of the silver ions in this 1.02 liters? So we know the number of the moles. The number of the moles here is, this is the number of the moles. This is what we calculated, 2 into 10 to the power -5, and the volume of the solution is 1.02 liters, right? So this is the volume. Now you simplify it, this one, it will come out to be 1.96 times 10 to the power -5, right? This will be the concentration of the silver ion. Okay, the concentration of silver ions. And now what about the chromate ions here, the chromate ions in it? So the chromate ions, we can again, in the same way we can find it out. We can find out the chromate ion. We have the number of moles equals concentration into volume. We can use the same formula, same method here. The number of the moles here will be equal to the concentration here is 0.002 into the volume here is 1000 mLs. So I can say it is 1 liter. So again you can say it is 0.002, or you can say it is 2 into 10 to the power negative 3. This is the number of the moles of this, the chromate. And now what is the concentration of the chromate in the final solution? We have a final solution that has a volume of 1.02 liters. So the concentration will be 2 into 10 power negative 3 divided by 1.02 liters. So again, when you simplify it here, it will be 1.96 times 10 power negative 3. Now this is the concentration of the chromate ions here, the CrO4 2 negative. Now ionic product we know is ionic product. Ionic product here is the concentration of the silver ions, okay, power 2, because you have 2 silver ions, okay, 2 silver ions, silver power 2 into the concentration of the chromate ions here. So we have just calculated that the silver ion concentration is 1.96 into 10 power negative 5 here. So you can make a square of it into the concentration of the chromate ion, which is again 1.96 into 10 power negative 3. Now this is the the ionic product. Okay, so we can simplify this one. The ionic product here now 1.96 into 10 power negative 5 square here. And this one, when you simplify the whole, this whole thing, it will be 7.53 times 10 to the power negative 13, right? Now, if you compare, looking at this, the two values here, the ionic product of this, the solution, the final solution, has a concentration of the silver ion concentration square the chromate ion concentration. When you compare it with the solubility product, look at here, the solubility product is much higher than this one. The ionic product is less, right? We can say it's the condition which is like this, okay? Ionic product is here is less than the solubility product. Solubility product is 10 power negative 12, and this is 10 power negative 13, right? So it is less. Ionic product is less than the solubility product. That means the solution is unsaturated. That means no precipitation can take place, right? So the no precipitation will take place. Okay, precipitation will only take place if this ionic product will be more than 10 power negative 12, right? Hope you got it. Thanks for watching the video. Bye for now.